And last point we have seen what is the permutation. So how to find permutation of any group. So here they have given one set S and that set is containing three elements as A, B, C. So P of A means what? Permutation on A, it gives element C. So that permutation is represented here. P is for permutation. So here once you apply this permutation P on A, you will get C. Okay. So likewise permutation of B, that is equals to A. So permutation of P on B, it gives A. P of C is equals to B means what? If you apply this permutation P on element C, you will get B. So after that we have seen how to find permutation table. So here 6 permutations are given: P1, P2, P3, P4, P5 and P6. And we have seen how to represent all these permutation diagrammatically. So if you consider permutation P1, here we have mapped element 1 into 1. So 1 is mapped into 1. That's why direction of arrow is from element 1 to 1. If you consider second column, second element, that is 2 is mapped into 2. That's why arrow from 2 to 2. And 3 is mapped into 3. So arrow from 3 to 3. So likewise we can draw diagram for any permutation. So after that we have seen how to find permutation table. So all these permutations are given here, P1 to P6, and we have to find out this table. Okay. So last time we have taken example for 2 elements, but here in this set there are total 3 elements and we have to find permutation table. So last example we have seen where permutation P1 and P2 were given and those permutations are defined on set S and that is containing 2 elements. So have you remembered how to find permutation? Okay, so I will explain you once again. Suppose two permutations are there and we have to find permutation of P1 with P1. Okay, so what is meaning of this permutation P1? It is consist of AB, AB. Now we have to take its permutation with P1 only. That's why AB, AB. Again second permutation is AB, AB. Now we have to check whether second and third element are same. If these two elements are same, then we can directly cancel it. Otherwise we have to make it similar or same. Now in this case, second as well as third element, these two elements are same as AB only. That's why this AB, AB will get cancelled. You will get AB, AB as a final answer. And AB, AB, this is permutation for P1. So value for P1 permutation P1, it is P1. So likewise we can find out the value for P1 permutation P2. Now value for P1 is AB, AB that we have written here. Value for P2 is AB, BA. AB, BA. So again check whether value for second and third element, these two are same. Yes, these two elements are same as AB, AB. That's why we can cancel it, and after cancellation you will get AB, BA. AB, BA. And this is the value for permutation P2. Now we have to find what is the value for P2 permutation P1. Now value for P2 is AB, BA. Okay, that we have written over here, and value for P1 is AB, AB. Now check whether second and third element, these two elements are same. No, second element is BA and third element is AB. So in order to make these two elements same, we have to change this AB into BA. That's why just we have to shift the or interchange the columns. So BA, BA. So after interchanging these two columns, we will get BA, BA. Now check Now here second and third, these two elements are same. That's why we can cancel it. And after cancellation, what we will get? ABBA, and that is the value for permutation P2. Now just one permutation is remaining, and that is P2 permutation P2. So again value for P2 is ABBA. So same value we have to take because second permutation is P2 only, ABBA. So again we have to make this second and third elements same. So BA is the second element. So third element should be BA only. So in order to make it BA, we have to interchange the columns. So AB becomes BA and BA becomes AB. Now check this second and third element, these two are same. That's why we will get answer as ABAB, and this is the value for P1, permutation P1. So likewise here we have find the values for all the permutations. So I think we have covered this example in the last lecture. Am I right? I think we have
Yes,
seen.
ma'am.
Yes, ma'am. Yes.
Okay. Now, similar concept we have to apply here, but in this example, set S is containing three elements as 1, 2, 3. So there will be total how many permutations? 6 permutations. So what is the formula to find out number of permutations?
N factorial.
Is n factorial. And here value for n is 3. That's why we will get n factorial plus 3 plus 3 value for n is 3. That's why this is the permutation P1. So value for P1 is 3. So here for this set S, all 6 permutations are given, and those are
Ma'am, voice is not audible.
now check it.
Now it is clear.
Okay. So all those 6 permutations are represented as P1, P2, P3, P4, P5 and P6. So for this we have to design this permutation table. So this is the symbol for permutation. Again 6 elements are there, that's why 6 rows will be there and 6 columns will be there as P1 to P6. Okay. Now consider first permutation, and that is P1 permutation P1. So whatever result we will get, that we have to display over here. So first one is P1 permutation P1. So value for P1 is 1 2 3 1 2 3. So I have written here. Again second permutation is P1 only. So 1 2 3 1 2 3. So again this second and third element, these two are same. That's why we will cancel it and we will get value as 1 2 3 1 2 3. That is permutation P1 only. So likewise you have to find all these permutations. So take time of 10 minutes and check for all these permutations. Just one permutation I have shown here, that is P1 permutation P1, and result is P1. That's why I have written here P1. So likewise you have to solve it. At least complete first two rows for P1 P2. Are you able to solve this?
Yes, ma'am.
Okay. So try it, and if possible try for all these values. So first of all try to complete for first two rows, then we will see remaining ones. Take time of 10 minutes and complete it. Hello. Have we completed?
Yes, ma'am.
Okay. So tell me values for P1, row P1.
P1, P2, P3, P4, P5, P6.
Okay, and for P2?
P2, P1, P5,
P2, P1, P5, P6, P3, P4.
Yes, correct. So likewise, you can take all remaining these permutations and you can form this table. So this kind of questions they may ask for 8 marks. And I think this is very simple concept. You have to just take permutation. Okay. So now we have to see next point as semi groups and homomorphism. So before this we have seen what is the concept of semi group, then sorry, subgroup and homomorphism. This is the name. Hereafter we have seen semi group, then monoid, sub semi group, sub monoid. So likewise we have to see what is a subgroup. So we have seen definition for group. Same concept we have to apply here. Let G star be a group and S is a subset of G be such that it satisfies following conditions. Condition number 1, E belongs to S where E is an identity element for G star. Second, for any element A belongs to S, inverse of that element, that is A inverse, belongs to S. And third one, for any two elements AB belongs to S, A star B belongs to S. Then only A star is called as subgroup of G star. So whatever concept we have seen for set subset, that same concept we have to apply here. Again, group, it is satisfying an identity property, inverse property and closure property. So all these three properties there should be in subgroup A star. Okay, so first here we have taken two groups. First one is G star, second one is S star. Then S star is called as subgroup of G star if S is a subset of G. And if S is following S is satisfying following conditions. First one, condition for an identity element, that is if E belongs to G, then E should belongs to S. If this is correct, then that is subgroup. Second one, for any element A belongs to S, A inverse belongs to S, because we have seen an inverse property for group. So what we have seen in that property, there should be inverse for each and every element of group. And third one, it should satisfy closure property. So if you take any two elements A, B, those belongs to S, A star B should belongs to S. Then only A star is called as subgroup of G star. So this is the definition for subgroup. Have you understood? Hello?
Repeat,
Okay.
ma'am.
Explain what, ma'am.
Yeah. So subgroup means what? That group must be subset of given set. Okay. So if you consider G star as a group, here G is a set. So whatever we are going to consider as subgroup, that is S, and that should be a subset of G. That's why I have written here G star be a group and S is subset of G. म्हणजे काय, जी मध्ये जेवढे इलेमेंट असतील तर त्याचा सबसेट हा तुमचा एस असला पाहिजे. अँड अगेन सेकंड पॉइंट इज दॅट whatever properties G is satisfying, all those properties should be satisfied by S. So first important condition, S should be subset of G, and second condition, all the properties of G should be satisfied by S. Now what are those properties? First property is for an identity element. So there should be an identity element E belongs to S, where E is an identity element of G star. म्हणजे काय, जर E हा आयडेंटिटी इलेमेंट असेल आणि जर तो G मध्ये असेल म्हणजे ग्रुपमध्ये असेल, then that element should belongs to S. Second one, there should be inverse for each and every element of S. So for if you consider any element A that belongs to S, A inverse should belong to S. And third one, it should satisfy closure property. So if you take any two elements A, B, then we are going to apply this operation star on these two elements as A star B also belongs to S. If all these three properties are satisfied by S, then A star is called as subgroup of G star. Have you understood now?
Yes, ma'am.
Yes, ma'am.
Okay. Now next definitions are for trivial subgroup and proper subgroup. Okay. Now consider here two groups are given. First one is G star, second one that is containing an identity element E and operation star is there. So these two, that is G star and identity element, these two groups are called as trivial subgroups of G star. Means what? If G star is a given group, then we can define only two trivial subgroups. First one is that group itself, and second one is any group that is containing an identity element, that is E. So these two are trivial subgroups, and all other subgroups of G star are called as proper subgroups. म्हणजे काय, आपण काय म्हटलं, if G star, if this is the group, then G star and any set that is containing an identity element E, these two are called as trivial subgroups, and all other subgroups are called as proper subgroups. So these two definitions are important. Most of time they have given question as define following terms like trivial subgroup and proper subgroup for 4 marks. So at that time you have to give these definitions. So have you understood what is meaning of these two definitions? Trivial subgroup means what? That group itself, and second one, any group that is containing an identity element E. So these two are called as trivial subgroups, and all other subgroups are called as proper subgroup. म्हणजे हे दोन सोडून रिमेनिंग जे असतील ते सगळे काय असणार आहेत, प्रॉपर सबग्रुप. हे झालं इफ यू कन्सिडर युअर ग्रुप ॲज G star. नाउ सपोज युअर ग्रुप ॲज A star. So what are the trivial subgroups for this group A star? What we have seen, that group itself, that is the first trivial subgroup, and second one, any group that is containing an identity element only. G star ला आपण काय म्हटलं, for this G star there are two trivial subgroups. First one is that group itself, means what, G star, and second one, any group that is containing an identity element only. So A group that is with identity element E and operation star is defined on it. So that is called as trivial subgroup. Now consider your given group is S star. So S is a set and we have defined operation star on it. So now tell me what are the trivial subgroups for this given group. What will be the first trivial subgroup? What was my first statement? The first trivial subgroup is group itself. त्याचं मिनिंग काय आता जो तुम्हाला ग्रुप दिलाय दॅट ग्रुप इज इट्स ट्रिवियल सबग्रुप. म्हणजे जर तुमचा जी स्टार हा ग्रुप असेल देन फर्स्ट ट्रिवियल सबग्रुप इज जी स्टार अँड सेकंड वन इज एनी ग्रुप दॅट इज विथ अन आयडेंटिटी इलेमेंट ई. So likewise, if S star is a group, then again for this S star there will be two trivial subgroups, and out of these two, first one will be S star, that is group itself, and second one any group with an identity element E, that is E star. So these two are trivial subgroups, and all other subgroups are called as proper subgroup. म्हणजे काय हे दोन ट्रिवियल सबग्रुप सोडून जे बाकीचे असतील तर ते काय असणार आहे प्रॉपर सबग्रुप्स. Now next definition is for group homomorphism. So again, in order to show homomorphism we have to take two groups. Let G star and H delta be two groups and a mapping G that is defined from G to H is called as group homomorphism from G star to H delta if for any two elements AB belongs to G. Now for first condition we have to take operation of first group, that is G of A star B, that is equals to G of A delta G of B. So this is as same like that of the homomorphisms of semi-group monoid. So what we have done here, first one, function G is applied on two elements A and B. If you want to apply this function G on these two elements, we have to consider operation from first group, and that operation is star. That's why G of A star B. Now if you want to apply this function G separately on elements A and B, then you have to consider operation from next group, and that is delta operation. That's why G of A delta G of B. So this equation becomes G of A star B is equals to G of A delta G of B. Now first condition is clear. Now we have to check for second condition, and that is for an identity element. So G of EG means what? EG, this is an identity element for group G. So if you apply this function G on the identity element of group G, you will get identity element for group H. That's why G of EG is equals to E of H. And third one, this is for an inverse element. So if you apply function G on inverse of any element A, you will get G of A bracket raised to inverse. So these are the three conditions required for group homomorphism. First condition is common, just you have to write for second and third. Again, this second condition we have seen in monoid. So for semi-group homomorphism, we have to write up to condition number 1. Again, for monoid homomorphism, we have to add this second condition as well. And for this group homomorphism, we have to add one more property, and that is for inverse property. So for this group, we have to define all these 3 conditions. So that will define group homomorphism. Have we understood this definition? Hello?
Repeat ma'am, group homomorphism.
Okay. So here we have to show homomorphism between 2 groups, and those 2 groups are G star and H delta. Okay. Now we have to take one mapping G, and that is defined from capital G to capital H. So this is called as group homomorphism. If you take any 2 elements A comma B belongs to G. Now how we can define the homomorphism? First, if you want to apply this mapping G togetherly on these 2 elements, at that time you have to take operation from first group, that is G of A star B. So what we have done here, we have taken operation from first group, and we are going to apply this mapping G togetherly on or at the same time on elements A and B. Now suppose if you want to apply this function G separately on A and B, at that time you have to consider operation from second group. That's why G of A star B is equals to G of A delta G of B. Up to this, is it fine?
Yes ma'am.
Okay. Now, so for semi-group homomorphism, we have seen this concept. Now, second one is for an identity element. So, if you want to apply this function G on an identity element for group G, you will get an identity element for group H. म्हणजे काय, जर ते फंक्शन G तुम्ही आयडेंटिटी इलेमेंट Gचा कुठला आहे E ऑफ G त्याच्यावर अप्लाय केलं तर तुम्हाला आयडेंटिटी इलेमेंट ऑफ ग्रुप H मिळेल, दॅट इज E ऑफ H. So if this condition is true, then we can say that is this is group homomorphism. And third important condition, this is for an inverse element. So if you consider any element A belongs to G, so inverse for this element A is A inverse. Now if you apply the function G on A inverse, you will get G of A ब्रॅकेट रेस टू इनवर्स. म्हणजे काय, हे जर फंक्शन तुम्ही ए वर अप्लाय केलं तर तुम्हाला काय मिळणार, जी ऑफ ए रेस टू इनवर्स. दिस -1 मीन्स वॉट, इनवर्स ऑफ दिस जी ऑफ ए. So if all these conditions are satisfied, then we can say that these two groups are in homomorphism with each other, or this is group homomorphism. Have we understood now? Hello. Second condition समजले का? For an identity element.
Yes, ma'am.
Third one.
Yes, ma'am.
Okay. So again, same definitions we have defined, like monomorphism, epimorphism, isomorphism, endomorphism, and automorphism. All these definitions we have seen with respect to semi-groups. So first one is for monomorphism. A group homomorphism G is called as monomorphism if G is 1 to 1. We have seen already, if that function G is 1 to 1, then that homomorphism is called as monomorphism. Second one, if that function G is onto, then that homomorphism is called as epimorphism. And last one, if that function G is 1 to 1 onto, then that homomorphism is called as isomorphism. So these definitions are very simple. Just you have to focus on that mapping G. So first one for monomorphism. Mono means what? There will be 1 to 1 connection. So if your function G is 1 to 1, then your homomorphism is called as monomorphism. For epimorphism, if your function G is onto, then that homomorphism is called as epimorphism. And third one is for isomorphism. If your function G is 1 to 1 onto. Why this one is called as isomorphism? Iso means what? Both. So if your function is satisfying both 1 to 1 as well as onto, then it is called as isomorphism. Now next two definitions are for endomorphism and automorphism. So first one is for endomorphism. A homomorphism from group G star to G star is called as an endomorphism. So if you are going to define homomorphism from first group to second group, that is called as endomorphism. While an isomorphism of G star to G star means what? If you define homomorphism between two groups, that is called as endomorphism. If we define isomorphism between any two groups, that is called as automorphism. So these definitions are very simple. Just you have to remember it, because these kind of questions they may ask you for MCQs. These definitions are asked for MCQs for 1 mark. So have you remembered what is meaning of all these 5 definitions? We will repeat once again. First definition, that is for monomorphism. If your function G is 1 to 1, that is called as monomorphism. Second one, that is for epimorphism. If your function G is onto, that is called as epimorphism. Third one, isomorphism. If your function G is 1 to 1 onto, that is called as isomorphism. Fourth one, endomorphism. If homomorphism from first group to second group is defined, that is called as endomorphism. And if an isomorphism between any two groups is defined, that is called as automorphism. So likewise, you have to remember all these definitions. Have you understood it? Hello? Do you have any doubt? Yes?
Endomorphism and automorphism. Repeat.
Endomorphism and automorphism. Okay. For this endomorphism, you have to remember keyword as homomorphism, and for automorphism, you have to remember keyword as isomorphism. Okay. So endomorphism means what? If you define homomorphism between any two groups, then that is called as endomorphism. And if you define isomorphism between any two groups, that is called as automorphism. So just remember, homomorphism is related with endomorphism and isomorphism is related with automorphism. So likewise, you can remember these definitions. So next part is based on Polish notations. that is quite different part. So I think we will start that part next lecture. So do you have any doubt regarding whatever syllabus of groups we have seen till so far? आतापर्यंत ग्रुपचा जो सिलेबस झाला आपला त्याच्याबद्दल तुम्हाला काही डाऊट आहे का? Okay. If you don't have any doubt, then we will take present T. Roll number 1,
Yes, ma'am.
2,
Yes, ma'am.
3,
Yes, ma'am.
4,
Yes, ma'am.
5. Roll number 5, 6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Present, ma'am.
10, 11,
Present, ma'am.
12,
Present, ma'am.
13,
Present, ma'am.
14,
Present, ma'am.
15, 16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21, 22,
Present, ma'am.
23,
Present, ma'am.
24, 25,
Yes, ma'am.
26,
Yes, madam.
27,
Present, ma'am.
28, 29,
Yes, ma'am.
30, 31,
Present, ma'am.
32,
Present.
30 and 31 are present. Okay.
32 present, ma'am.
Okay. 33,
Present, ma'am.
34, 35,
Present, ma'am.
36,
Present, ma'am.
37,
Present.
38,
Present, ma'am.
39, 40,
Present, ma'am.
41, 42, 43,
Present, ma'am.
44,
Present, ma'am.
45,
Yes, ma'am.
46,
Yes, ma'am.
47, 48, 49,
Yes, ma'am.
50,
Present, ma'am.
51,
Present, ma'am.
52, 53, 54,
Yes, ma'am.
55.
Yes, ma'am.
Who is 53? Roll number 53. 55, 56. 56, 57,
Ma'am.
58,
Yes, ma'am.
59,
Present, ma'am.
60,
Yes, ma'am.
61,
Yes, ma'am.
62,
Present.
63,
Present, ma'am.
64,
Yes, ma'am.
65, 66,
Yes, ma'am.
67, 68,
Yes, ma'am.
69, 70, 'check for absent numbers. Roll number 5, 7,
Ma'am, 7 present.
okay, 10, 15, 21, 24, 28, 34, 39, 41, 42, 47, 48, 52, 53, 56, 65, 69, and 70. So today we are going to stop here. Thank you.